Hey everybody, welcome to Algorithms Part 2. In this section, we are going to look at just 4 different areas that you might see algorithms in. So these would be maybe not in the exact area you would do them in your class, but you might look at algorithms to do these things throughout a high school computer science class. The first one, for sure, you're going to end up doing, and that is some sort of sorting. Okay, so sorting. And we just looked at an example of sorting. We had, boxes that were like 3, 4, 1, I think it was 2 here. I think that was the order we had. And we sorted these in order of least to greatest, and we were moving boxes around this way and that way, and getting things to sort out in order. And that's what you do in most sorting algorithms. It's something along the lines of swapping or switching things. And a couple algorithms we have are things like the bubble sort, which is probably the first algorithm for sorting that you would see in a computer science class. And you actually will see this later in the series that we're doing now. Not the algorithm series, but further on after we've looked at algorithms in more theoretical detail, let's say. Something also like selection sort, and these are used, but not so common as something like a quick sort. And not in class, you'd probably use the first two, but in real life, people use quick sort or merge sort. Okay, so these are much quicker sorting algorithms, and usually it's related to numbers when you're doing any of this sorting. Okay, so that's just kind of some sorting algorithms. It's usually just about putting things in order, and these first two, they'll work on a lot of things that are not big data sets, but oftentimes people want to sort really big chunks of data. They maybe want to sort like 1 million different numbers, and they want to put them in order. Maybe you're sorting stuff by social security number, or you want to sort, maybe you're ranking something from the most to the least, whatever it happens to be. Maybe I don't know, people have collected amount of certain coins for their coin collection, and you want to sort the whole list by who has the most coins. Okay, so quick sort and merge sort will do that a whole lot faster than the first two. Okay, so let's look at another type of algorithm here. Another type of algorithm that you might see would be something like trees. Okay, and trees are actually, they're kind of more, it's a data structure than it is in anything with an algorithm. But there's a lot of algorithms that come along with trees. So trees, I'm going to write data structure here. So data structure, what I mean by data structure is a way that you store information. So probably the most common thing that you could possibly think of would be a family tree. So maybe we have a family tree with, I don't know, somebody up here, and there's family there, and then he's got his wife over here. I'm not doing, she's over here, and then they have kids, right? And those kids, there's maybe multiple children down here, and then one of these kids marries somebody from hopefully outside the family, and then they create some more children and stuff like that. And this tree could go on and on for a long time. You could go back in time like 1,000 years, and maybe you want to trace the ancestry of somebody, or maybe you want to find in this tree, you want to find all people that are named Henry, and maybe there's like 18 Henrys in the list, but you want to find all of those Henrys, and you want the computer to find it, as opposed to you looking at this giant 1,000-year-old family tree, which would probably cover multiple wall spaces. So you build a tree structure inside the computer, and it goes through this. And these are often related to search algorithms, which I'm going to talk about in just a minute. But you're searching through the tree. But at the same time, there's also algorithms for building trees. So maybe you are compiling a set of data. Maybe this data, you want to be able to search through it very quickly, and so each piece of data is going in the tree, and you start with the first top of the tree, and then that is related to this data here. Or maybe you're just sorting the information here, and then so the data goes in, and then you add more things, but you're trying to keep this tree so it's not too lopsided. You don't want too much data on one side, or you don't want a really long line of data like this. So you got to reorganize the tree, and that's an algorithm as well. You want to reorganize this tree so that it's more balanced, so it looks, like a tree like this. So it's all balanced nice and neatly on both sides, and there's not too many of these little circles on one side or the other. Okay, we'll talk about trees in the more advanced section, but right now just think about trees are a data structure, but there's algorithms that are used to build the tree, and there's also algorithms that are used to search the tree. All right, so let's just look at another kind here. Another kind of algorithm you might see is something like pattern matching. And pattern matching is pretty common. Pattern matching happens with things like DNA. This is actually a pretty common thing nowadays. Maybe you have a piece of DNA that looks like this, and then you have over here, you have this massive file with all this DNA in it. Maybe it's, I don't know, like aardvark DNA or something. So you have aardvark DNA, and you've taken maybe a whole bunch of aardvark DNA, and you want to search through that. And this is a search thing, but it's also a pattern matching thing. So oftentimes you'll use this DNA and you'll do something to it in order to make this pattern matching happen quicker. But at the same time, maybe you want to search not for this exact piece of DNA, but you want to say, well, I want something that maybe matches this piece by 80%. And that requires a different algorithm than finding something exactly. You're going to have to find something that matches 80% of this. So that means, well, what does that mean? It means if I take one piece or switch one piece around, does it mean they all have the same, but maybe they're not in the exact same order? Is that the same? And different things. So there's a lot of algorithms that are involved in pattern matching. So pattern matching is something you will probably end up doing in your high school career. I'm not saying you're gonna search aardvark DNA or something like that, but you might do some type of pattern matching in a large text file, for example. Okay. The last one I want to talk about, and this is something that we are going to talk about in the next video as well, because we're going to do an example with this, and this is search. And much of the stuff I did up here, if I did these three up here, these often involve some sort of search. You're either searching for a number, or you're searching for text, or you're searching for something in a tree. And search, the search has things like binary search, and that's using a binary tree. You have other types of search. There's one called A star, and A star is it's a path algorithm, so it actually finds a path. So this is for path finding, and that's one way to search. You also have things like searching a file, or your internet search or something like that. These are all algorithms. You might have heard Google has their algorithm for searching, and it's true, they have some sort of algorithm that they use to take information and store it, and then to search through it so it happens really fast. And every search engine has their own algorithm for doing that. Google has Google Ranks and ranking and things like that, and it's changed over the years. They all are always changing that stuff. But search is something you might do if your teacher asks you to search through a whole bunch of files or something like that in order to find information. And this right here is what you might do if you ever decide to make a video game, because any video game where you have a character that needs to move around is going to probably use something similar to A star, if not A star itself. So this pathfinding thing is very, very, very useful. Like, have you ever thought about when you're playing a game and you click some part of a map and your character walks up there, how it gets there? Well, there's a pathfinding algorithm that tells it how to get there. And we're going to talk about pathfinding, and we're going to talk about that in relation to search in the next video when I do an example. So see you in the next video, and if you have any questions on this or your comments, if you want to add on perhaps some other things that I didn't cover, feel free to put it in the comments on YouTube, or you can put it in the comments on the website. All right, thanks for watching.